Continuing sections 3.4 and 3.5, this is part 5. We have been given bits of information and we have been plugging them into formulas to get equations. Everyone we've worked so far, we have been given the slope, but that's not always going to happen. If you are not given a slope, you will be given enough information to find the slope. So not only are we going to have to remember these formulas, we also need to remember these. Okay? I want to find the equation of the line that passes through the 2 points given. So these 2 points. Write our answer in slope-intercept form. So we've changed forms again. All right. So in order to use any of these are the 2 we could potentially plug into. I have to have a slope given, and I don't have a slope given. So I look to see, can I find the slope if I'm given 2 points? Absolutely. So this is my first step. I need to plug in here. Now remember, it doesn't particularly matter which one you call x1, y1, and which one you call x2, y2, just so long as your your 1's are together and your 2's are together. This slope is y2 minus y1, so 4 minus 2, over x2 minus x1, negative 3 minus 1. So doing the arithmetic, 4 minus 2 is 2. Negative 3 minus 1 is negative 4. So I have negative 2/4, which is the same thing as negative 1/2. So the slope I need to use is negative 1/2. Okay. So now I have a slope, so I could use one of these, but I can't use this one because I'm not given the y-intercept. I'm going to have to use this one. Now you might be wondering, how do you know which of the 2 points to use for your x1 and your y1? The truth is, it does not matter one tiny little bit. You will end up with exactly the same answer no matter what. So pick the numbers you think look easier. And I think these 2 look easier because no negatives involved. So I'm going to use this one into this formula with this slope. Okay, so y minus y1, y1 is 2, equals your slope, which is negative 1/2, times x minus x1, and x1 is 1. Okay. Now we don't have any double negatives in here to clean up, which is always nice. I am going to distribute a negative 1/2. I get y minus 2 is equal to negative 1/2 x. 2 negatives multiplied together is a positive 1/2. Okay, so I would do this much no matter which form I'm supposed to go into. I'm supposed to go into slope-intercept form, which means I need the y alone. All I really need to do is to add 2 to both sides. If you want to kill the fractions at this point, you can do it, but the fractions are going to come back. There's no way to get rid of them forever when you're going into slope-intercept form. Okay? So centric calculators will do fractions. That's always a good option. If I'm just going to add 2 to both sides, on my calculator, and most scientific calculators will do fractions. You might need to look in your instructions. If I add 2 plus 1/2, it gives me my answer in as an improper fraction. I get y equals negative 1/2 x plus 5/2. Now without a calculator, how did we do that? I did 2 plus 1/2. And I need to write 2 as a fraction, so I put it over 1. Since I'm adding, I need a least common denominator, which would be a 2. So I need to rewrite each of these with a denominator of 2. This one already has a denominator of 2, so the top does not need to change. Going from here to here, I multiplied by a 2, so I need to multiply the top by a 2 as well, which will give me 4/2. Now add across the top. 4 plus 1 is 5 halves, which is what I have right here. This is your solution. One thing I want to encourage you to do is that this number right here, the number in front of your x, should be your slope. Double check it with your slope. It's a quick thing, but they should be the same number. And if they're not, you definitely made a mistake somewhere.